Welcome to Homework Lib.
Okay, so we have a self-inductance problem with quite a bit of information. So let's just go ahead and record all the numbers we have. It is a toroid, so we do know its cross-sectional area as well as its radius. And then I'm going to go ahead and convert everything into SI units to make our lives easier later on. So that is the radius of the donut. That's what a toroid is. And so let's use the self-inductance equation in part A in order to find the self-inductance. So that is going to be number of turns multiplied by magnetic flux divided by current. So we know almost none of those. So we're going to have to make a lot of substitutions. Starting off with magnetic flux, we know is going to be magnetic field multiplied by a cross-sectional area. Furthermore, magnetic field caused by a current is going to be equal to U naught N I. We have current on top and bottom, so those are going to cancel out, which is good because we don't know what the current is. And then make another substitution for the number of coils per unit length for a toroid. Looks like that. And finally, we can collect all the terms and get n squared u naught a over 2 pi r. And finally, this is in the form where we can plug in numbers. So let's start a second line. We have n is 500. Mu naught is 4 pi times 10 to the minus 7. Area 2 pi, and then toroidal radius. Plug all those in and then get a self-inductance of 7.81 times 10 to the minus 4th henries. Move on to part B. We want to know what the induced EMF is based on some initial conditions that are given to us. So we can solve for the how fast the current is changing based on some numbers that they give us. Let me just write those out. So that's how fast the current is changing. So we can find the induced EMF. Oh gosh, okay, sorry, I'm running out of space. Induced EMF is going to be equal to 0.781 volts. I think I can put a box around that down there. Good, good, good. And then lastly, in part C, we just want to know the direction that this induced EMF is. And it primarily has to do with the sign at which the current is changing. So the current is decreasing. So the induced EMF is going to be in the same direction as the current, which is going to be A to B.